Today's objective is going to be combinations and permutations. There will be a quiz tomorrow that could cover everything that we've done since the last test. There we go. I have to put a T in there. There it is. Combinations and permutations. Flashcard. Say the answer when you know. 720. 6. 2. 12. 36. 'This one is 24. This one is 120. 144. 7. 56. 72. 90. This will be an example. This is how you figure these out without having to use a calculator. If I put up 8 factorial over 6 factorial, you have to keep in mind that that's 8 times 7 times 6 all the way down to 1. And on the bottom, that's 6 times 5 times 4 all the way down to 1. This cancels out with all of that. You're left with only 8 and 7. So the answer is 56. $132. Now you have the hang of it. $20. 120. 7. Here is example 1. And the first example is lovely. It has 1, 2, 3, 4, 5, 6 letters in it. 6 factorial. Do any of the letters repeat?
Yes, L.
We have 2 L's in there. So we have 6 letters total, but we have 2 L's. 2 factorial on the bottom. We want to find the number of ways we can arrange these letters to make a semi-appropriate word. Maybe one that can't be pronounced. Probably not even a word at all, but how many ways can you arrange the letters? It does not matter if this L is there or if it's here. It's an L. So that's why when we count up the L's, we divide by 2 factorial. Of course, we know that getting rid of 2 factorial from the top is going to give me 6 times 5 times 4 times 3. So that would be 30 times 12, which is 360. 360 ways we can arrange the letters in the word lovely in order to have a different arrangement. Here is example number 2. Week. 4 letters. How many repeat? 2. So that's really 4 times 3, which is 12. Makes no difference where you put the 2 E's. If I put this E here or here, it's still an E, and you can't tell the difference. These E's are not discernible because you don't have like a power on it or anything like that. A 2, a 1, or anything like that. They're just E's. Try this practice. On this problem, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different letters. We have 1, 2, 3 I's, 3 factorial on the bottom. And then we have 2 E's. Anything else that repeats? 2 N's, yes. Anything else that repeats? Okay, so 10 factorial over this stuff here on the bottom. We could take out 3 factorial from the 10. So 10, 9, 8, 7, 6, 5, and 4. But now we have 2 factorial times 2 factorial, which wipes out that 4. Of course, I'm doing this without a calculator. You can use yours. But that's a 30. That would be 210. And this would be 72, and then 720. 720 times 210. How about 151200, 151,200? On practice 2, the word is going to be Mississippi. On this problem, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers or letters total, and then we have the S that repeats 4 times, and we have the I that repeats 4 times, and we have 2 P's in there that repeat twice. We could have 11 times 10 times 9 times 8 times 7 times 6 and then times 5, and that would cancel that out on the bottom. Now 4 factorial is 24. So we don't have a 24 up there that we can create. Do we have a 48 that we can create? This is 24 and this is 2. Can I get a 48 from the top? 6 and 8 and knock those out. So those are gone. And we have 110 times 9 is 990. And then of course we multiply by 35. So 990 times 35. 34,650. A mid-class lottery will do that. And you pick a number from 1 to 10. The winning numbers for the mid-class lottery are 5, 7, and 8. Example 3. You have a set of letters that's going to create a word here, and it is going to be overused. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 letters is 8 factorial. What is used twice? E. Anything else? Only one U. Anything else that repeats in here? So I would really have 8, 7, 6, 5, 4, and 3. That's 30 and 90, 360. It would be 360 times 56. And 360 times 56 comes out to be 20,160. Example 4. Unbelievable. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. What repeats?
E.
E, how many? 3. B, 2. L twice. What else? Is that it? Okay, so we can knock this out. It would be 12, 11, 10, 9, 8, 7, 6, 5. And I couldn't get the 4 in there, so I'll just go down to the next one. And on the bottom, we have 2 factorial times 2 factorial is just 4. So that 4 cancels out with this on the top. Of course, this is 30, and with that would be 300, 2100. So we're going to have 2100 multiplied against 72. And then, what's that, 132? Alright, so 132 times 72 times 2100 is a very large number. 1,995,840. 19,958,400. For this one, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 letters. And then we have 1, 2, 3 ends that repeat. Anything else that repeats?
No.
Nope. So we'll have 8, 7, 6, 5, and 4. That's 30. And 120. 960. So we've dwindled it down to 960 times 7. That should be 6,720. Practice 4. For this problem, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. We have 1, 2, 3, 4, 5 I's. Anything else repeat? N, V, S, B, L, T, Y? Nope. So we really have 12 times 11, 10, 9, 8, 7, 6. Cancels out on the bottom. And let's see, that's a 42, 40, or 420 now, and a 72, and then a 132. So 132 times 72 times 420 is this very large number here at the top, 3991680. That is 3,991,680. This is an example. You have a set of elements. And in there, each check mark is an element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 elements in this set. The question is, how many subsets of this 10 element set can have 3 or 4 elements? For example, that's a 3 element set. That's a 3 element set. That's a 4 element set. How many different ways could there be sets that have 3 or 4? You can't say 3 and 4 because you can't have a set that has 3 and 4 elements. It either has 3 or 4. How many subsets can have 3 or 4 elements? That would be a combination problem. Combination means that order is not important. In other words, in this subset here, this could be there or it could be here. It's still in that set. So it's a combination problem. So you have 10 elements and you're going to choose 3. But then you also have 10 elements and you're going to choose 4. So we use the addition rule there to figure out how many possibilities there are. So for this, for the combination on this one, don't forget that's 10 factorial over 3 factorial times 10 minus 3 factorial. And then plus 10 factorial over 4 factorial times the quantity factorial of 10 minus 4. Of course, you can use your calculator and do the math. Either way you do it, the answer is 330. This is a practice problem. This is a set of elements. How many subsets can have 4 or 5 elements? For this problem, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 elements. So 14, choose 4, plus 14, choose 5. And the answer should be 3003. Bring this one up. Well, on this problem, it would be 4 factorial over 4 minus 2 factorial plus 6 factorial over 3 factorial times the quantity factorial of 6 minus 3, and then minus 3 factorial over 2 factorial times the quantity factorial of, I'm drawing a blank, 3 minus 2, there we go. And no matter how you do it, the answer should come out to be 29.